One of the most important components of a hydroelectric facility is a hydroelectric dam. A dam is a massive man-made structure designed to contain a body of water. Dams are not only used for water storage and supply for different commercial, industrial, and agricultural uses. Energy derived from the motion of running waters in dams, particularly in hydroelectric dams, can also be used for electricity generation. A hydroelectric dam requires two things to generate electricity: an abundance of water and a difference in elevation between the outlet and inlet sides of the dam. This difference in elevation is referred to as the head. The headwater is located upstream of the dam while the tailwater is situated downstream. These two are separated by the dam. The large body of water serves as the headwater, ensuring a continuous supply of water for power generation. The Philippines is no stranger to harnessing energy derived from hydroelectric dams. As such, the five largest dams in the country serve significant purposes. San Roque and Binga Dam in the Agno River generate power, supply irrigation for agriculture, and serve as flood control measure. Magat Dam in Magat River, Ambuklao Dam in Bukod, Benguet and Pantabangan Dam in Nueva Ecija also serve multiple purposes such as power generation and irrigation. Aside from power generation, irrigation, and flood control functions, there are a number of environmental benefits that can be derived in the construction of hydroelectric dams. Wetland species, particularly waterbirds, benefit from the establishment of the reservoir. It can also provide water to animals and plants in the surrounding area, which can be substantial environmental benefit in places that have become excessively dry. Impacts of mining and quarrying for construction materials. The resources needed to build dams and canals are usually mined and quarried near the dam or canal site. Such extraction has potential negative environmental impacts, particularly if it exacerbates pollution. This includes increased dust pollution, wildlife disturbance, and vegetation degradation. Impacts of backwater buildup. Backup pressure builds up when a free-flowing river meets a relatively static reservoir, resulting in a backwater. This has the potential to destroy the upstream ecology as well as the damaged property. Backwaters can also form as a result of a sediment and silt deposition upstream known as the backwater deposits. Impacts on aquatic ecosystems. Vulnerable species with limited distribution or low tolerance can become extinct before the dam is completed. Blocking rivers to form lakes can significantly change the ecological conditions of rivers, adversely affecting species and ecosystems. There are changes in pressure, temperature, oxygen levels, as well as the chemical and physical properties of water. In addition, disruption of water flow disturbs ecological continuity. Impact on terrestrial fauna and flora. The disruption caused by construction activities has a negative impact on the wildlife and flora at the dam site. As the impoundment begins, large tracts of forests and other ecosystems such as grasslands and wetlands are submerged. Impact on cultivated biodiversity. Reservoirs also submerge agricultural land in the valley. Aside from the social and economic costs, it also affects the cultivated biodiversity and a variety of birds, insects, mammals, and reptiles that have adapted to agricultural ecosystems. Water lagging and salinity. Canals can contribute to water lagging. Significant amount of water can seep out of canals and inundate the lands around them if they are not adequately lined or maintained. Water lagging can also contribute to salinity and provide an ideal environment for better breeding. It damages natural vegetation as well as houses buildings, and roads. Impacts of sudden release of water or dam failure. Degraded catchments, extreme rainfall, or overfilling may require sudden release of huge amount of water from the reservoirs to protect the dam structure. Such unexpected releases can be disastrous from downstream communities, their crop, and entire ecosystem. With hydroelectric dams harnessing the water resource of the watershed, its sustainability and effective use is highly dependent on the knowledge of the various factors involved in watershed management. The storage and operation of reservoirs are directly affected by the flow of water and sediment from the headwaters, which can be designed to fulfill one or more of the following goals: to provide water for irrigation, commercial and industrial needs, and hydroelectric power generation; to maintain in-stream flows during the dry season, and to provide storage to mitigate flood hazards. If flood control is the goal in watershed management, strategies that maintain high rates of infiltration and low surface runoff flows should be considered. Wetland regions within the watershed help to reduce storm flow peaks, hence their preservation should be a top priority. On the contrary, if the goal is to suffice the increased demand, land use and vegetation cover that facilitate low infiltration rate and high surface runoff should be practiced, increasing stream flow towards the catchment area. The storage capacity of the reservoirs should be well monitored. In order to determine its storage capacity, the inflows of water in the reservoir and the rates of sediment deposition must be balanced against future water demands. Stream flow monitoring plays a huge role in measuring storage capacity. Hydroelectric dams are complex engineering infrastructures built on some of the watershed in the country. They provide multiple benefits for our daily power and water consumption. While these benefits are very significant, their environmental impacts on the watershed should not be neglected. Building this kind of infrastructures should involve proper planning and consultation of multiple stakeholders. This will help address our demand for water and electricity while sustaining our watershed for the future generations.